All right, we're looking at a problem that models exponential growth. And in this case, we can see we've got a negative here, which is going to flip our graph over. So just this part alone would be growth, but now we're going to flip over the graph. So think about that. We're going to have an exponential graph that then gets reflected. So it's going to look something like this. And if we're thinking about our value of a car, values of cars start high and then immediately drop down. So that's sort of what we're thinking about, that we're going to buy a car and then its value is going to decrease the longer we own it. So we're starting from when we buy it at 0 years and then going to n years. All right. At n years, the value of our car is 0. So that's when our car has lost all its value. So somewhere, if I have my axes, something like this, something like this. So my value of n is going to be down here. And really, we're just looking at this portion of our graph from here to here. All right, after 2 years, the car's value is just over $9,000. So value and time are my two variables. So I know that this one means the point where I go 2 years and my value $9,143.20. All right, write down and simplify an expression for the value of car when Gabby purchased it. Well, that's at time 0. So my value at time 0 is going to be 12,870 minus k times 1.1 to the 0. Well, I know 1.1 to the 0 is just 1. So my value at time 0 is going to be 12,870 minus k. And we don't know, we're not asked for anything further, so we're going to stop here. All right, part B, find the value of k. So now we're going to use this point. So we're going to plug in our point. So we know that this is our value after 2 years. So now the right-hand side of my equation, my value after 2 years is 9143.20. So I can come substitute into, I'm going to substitute into my original one. So 9143.20 becomes my left side. My right side is going to be 12,870 minus k times 1.1 squared, because I'm plugging in my 2 for t. I'm going to use my calculator to figure this out. 1.1 squared $1.21 equals minus 1.21k. So now I'm going to subtract my 12,870 to the other side. And that should give me a negative number. Sorry, that's also negative, which is good because k is going to be, we think k is going to be a positive number. So divide both sides by negative 121. I can just hit divide, negative 1.21, and I get 3,080 as my value of k. So now knowing this, I could come back and plug it in over here to find how much my car actually was when I purchased it, but I'm not asked for that anywhere. So I'm just going to keep answering my questions. So now my value of n, well, I know that n is when my value of the car is 0. So we know that my value at year n is going to be 0. I want to find n, so I'm going to plug back into my original equation up here and plug in my k. So 0 equals 12870 minus 3080 times 1.1 to the t power. And now my t is actually my n, because that's what we're looking for. So I'm going to call this n because we're plugging in n for our t. And now I can't solve this one algebraically. So instead what I'm going to do is I'm going to go to my calculator. So I'm going to plug in what I know. And I'll use x here. And now I'm going to look at my table of values. So here's my starting value of the car. So if I actually plugged in my k, that's my starting value. My car value is decreasing, so I can see at 10 that I'm still not at 0. So I'm going to just jump up to 10. And now I can see somewhere in between 15 and 16 is when my car value goes through 0. So n, let's go back and read what we're told. We're told that t is the time in years where the car is purchased. At n, the car's value will be $0. So I can say that at 15 years, the value is not yet 0. At 16 years, it is past 0. So I could go back to my graph and find this exactly. Or I could say, if I want to answer in years, n would have to be 16 because I have gone to 0 then. At 15, I haven't yet gone to 0. So I could say 16 years, or we could use our graph to find it exactly. So I'm going to change my window. I know that it's going to be somewhere between 15 and 16 on my x's. And my y values went from about 4,000. Sorry, my minimum was about -1,000. My maximum was about 4,000. And I'm gonna not 40, 4. And I'll count by 500s. So now if we look at this graph, we can see that it was really close to the 15 where we crossed over. So let's, if we wanted to calculate this, let's go back to my table of values. 14, oh, not 4,000, it was 4. Okay, that makes much more sense. So we were really close at 15 years. So let's change my window to help me out a bit more here. So my minimum, we don't need to go down to the -1,000. We know it's really close to 15. So let's just go -1 and then make this 4. And now we can count by halves. Oops, graph. Okay, now since we're so zoomed in, it's so close to 15. Let's go ahead and calc our 0 value. So calc, we want the 0. So the left bound I'm going to say is 15. My right bound we could say is 15.5. But it looks like it's really, really close to 15, so I'm going to guess 15.1. And we can see it was so close to 15 years that even if I rounded this, so I could actually say that n equals 15.0, and that is to 3SF. So if I rounded to 3 significant figures, I would say this. If I'm going to use my calculator, I'm going to draw my graph and let the grader know that I know that at 15 years it's not exactly 0, but that when I calculate it, it's so close to 15 that I can round to 15.0, but putting in the 0.0 shows that I've rounded to that value.